This is Chapter 22, Information Security, and this is Group 8's presentation by Garrett Bond, Darren Yazzie, and Myron Judkins. The first slide integrates security into development iterations. We need to have future teams engaged with InfoSec as early as possible. There's 3 points here that we need to emphasize. First, we need to ask InfoSec to provide guidance and feedback at the earliest stages of the project. We also need to invite InfoSec to the product demonstration so that they can better understand the team goals. And last, invite InfoSec to observe team implementations as they are being built. Next, we integrate security into defect tracking and postmortems. And we must track all open security issues in the work tracking system that development and operations are using. And anytime we have a security issue, we conduct a postmortem in order to better educate our engineers on how to prevent future problems. We also need to integrate preventive security controls into shared source code repositories and their shared services. We add any mechanisms or tools to our shared source code repository to help enable us to ensure our applications and environments are secure. And examples of those are the code libraries and their recommended configurations, secret management, OS packages, and builds. The display here is just an example of branch security. Next, we integrate security into our deployment pipeline. Now, we provide both development and operations with fast feedback whenever they make commit changes that are potentially insecure. Once we do that, we run automated security tests in our deployment pipeline alongside the other static code analysis tools. And that's how we integrate security into our deployment pipeline. Next, we ensure security of the application. This is part 1 of 2 slides. First, we conduct static analysis, which is performed in a non-runtime environment. And we search for runtime issues like backdoors, coding flaws, and malicious code. Then we conduct a dynamic analysis, which is performed when the program is in operation. And it analyzes system memory, functional behavior, and response time. In part 2 of ensuring security of the application, we do dependency scanning, which is performed at the build time. And what that does is it checks any and all dependencies to ensure that no vulnerabilities exist. Then we look at our source code, make sure the source code integrity and code signing. PGP, or Pretty Good Privacy Key, is a secure way of signing, encrypting our source code. Now, once we secure our application, next we ensure the security of our software supply chain. Now, security vulnerabilities are often inherited by whatever original source they may come from whenever we implement them into our code. Current threats today to our supply chain, most organizations depend on 7601 software suppliers and or their components. Now, 7.5% of the 7601 has publicly known vulnerabilities, and 66% of the 7.5% had been publicly known for the past 2 years. Next, we ensure security of the environment, and we do that by the settings, and we make sure that they have been configured properly, and this can be done via automated testing. We also need to understand the actual environments. Tools that can be used to check this could be Nmap or Metasploit. The purpose of checking our actual environments is to ensure that any recently made changes are not creating vulnerabilities. Next, we integrate information security into production telemetry. Now, security breaches are often found several months after they occur. Internal security controls are ineffective because there is no telemetry in daily work. To counter this, we must monitor, log, and alert in order to fulfill information security objectives. We also integrate security telemetry into development, Q&A operations so that they are all thinking of security risks daily. Next, we create a security telemetry in our applications and environments. In order to identify problematic behavior, we must create relevant telemetry in our applications. And examples are success versus unsuccessful logins, password resets, email address resets, and credit card changes. The last thing we must do is protect our deployment pipeline. We must mitigate the attack vectors in our deployment pipeline. And other mitigating strategies include hardening continuous build and integration services. We also review all changes in version control. And we also instrument the repository to detect suspicious activity and make sure every CI runs on its own and credentials are read-only.